Hello everyone. So in the last session, we covered some basics of the KiCad schematic editor. We learned a few basic things on how to place a component, how to connect two components via wires, how to connect them with net labels. We also covered some fundamental concepts of motors. We also discussed why we're using some diodes. Now, the objective of this course is not only to help you build projects, but develop some fundamental concepts that you would need to build your own projects. So, in this session, today we'll discuss about why we need capacitors in our PCB designs, what is their role, and how do we use them. The reason you need to know more about the capacitors because they are one of the most frequently used components in PCB design. So you should be very comfortable while using them in your own projects. This is a picture which has different kinds of capacitors which you may or may not see. This is the electronic symbol of a capacitor which has thus two parallel lines. Now, what exactly are capacitors? Well, think of them as tiny banks that stores electrical energy. Okay, these components they can store and release electrical energy. This simple definition should be good enough for now. So let's just see why do we even need capacitors. Let's just consider this very simple circuit. So you have some IC. It can be any IC. Let's say L298 or the IC 555 or anything. It could be anything. So it will have some power pins, right? It will have one VCC pin and one ground pin. Okay, and you are supplying this power pin through some battery. Okay, these are some pins that might have their own purpose. So currently we are just focusing on these power pins. So let's just see why capacitors came into the picture. So if we go inside the IC, if we go inside the IC, there are some things called transistors. Okay, if you don't know, just think of transistors as switches that can turn on and off. So any electronic device that you come across, they have a very large number of transistors inside them, and these transistors they turn on and off very rapidly. So the IC demands a large current from the battery when this transistor switching is happening inside it. Okay, now let's just see. Okay, let's just see this circuit. Okay, this is very simple. So we have our IC and the battery is providing it current. But the problem is in practical circuits, these wires that you see, this wire or any connectors, it will have some sort of resistance as well as some inductance. Okay, and the property of inductance is that it resists sudden change in current. Okay, but you know the IC, this IC, it will require a large amount of current. Okay, it will be something like this. So it will require a large amount of current in an instant. Okay, but these wires or these connectors that we are connecting with the battery, they will have some resistance and some inductance. So it won't be able to provide this current that this IC instantly needs. So what we'll do is right next to the power pin of the IC, we'll put some sort of a capacitor. Okay, we'll put some capacitor right next to the IC pin. So when this IC needs a lot of current in an instant, this capacitor will provide it locally instead of being the IC being dependent on this battery for its current. Okay, so we'll put some sort of capacitor right next to the IC pin so that it can provide the instant need of current by the IC instead of relying on the battery. And why is that? Because the connector to the battery or the wire, it will have some sort of inductance which resists this sudden change of current. So we're creating some sort of a local supply here by using a small capacitor. So this capacitor which is kind of separating this battery and this IC. Okay, it is kind of separating this battery in the and the IC in the sense that it is providing the current locally when the current is needed instantly. Okay, so it has a specific name. Okay, this kind of capacitors are called decoupling capacitors. So whenever you are building some project that uses some IC which switch very fast, then you need to use some decoupling capacitor. The two main purpose of this decoupling capacitor is it provides the instantaneous current needs of this IC, It also helps in filtering noise. So let's just see how it does that. So this IC, it will demand the current. Okay, it will demand current something like this. Okay, let's just say this is current and this is time. Okay, so it will demand the current suddenly something like this, then it will drop and it will again spike and it will again drop and it will again spike and it will again drop. So these sudden spikes are due to the transistor switching inside the IC. So it is very noisy. And typically our battery or the power supply, okay, it, it supplies the current in a smoother fashion. Okay, so in a constant manner. Now assume that there is no decoupling capacitor. Okay, so assume that there is no decoupling capacitor. Okay, so now this current spike will have to be provided by this battery itself, right? So there will also be some voltage drop. Okay, there will also be some voltage drop in this power supply rail. Okay, in this power supply rail, there will be some voltage drop. Why? Because of this sudden current spike. Okay, now the problem is if if there is no decoupling capacitor as we see here and we are using the same power supply. Okay, typically this is the case where we'll use the same power supply for more than one circuit. Okay, we're using the same power supply for more than one circuit. This battery, it is providing power to both the circuit 1 circuit 2 on this IC. Okay, this circuit 1 and circuit 2 could be anything. Let's just say some IC or some any other circuit. But the problem is if we don't have a decoupling capacitor and this IC, okay, this IC is demanding current something like this. Okay, and what will happen is there will be some voltage drop across this power supply rail. Now this voltage drop will also be felt. Okay, this will also be felt by this circuit 2 and circuit 1. And we know that each component or each IC, they have some standard voltages that they can operate on. And if this voltage drops below that threshold voltage, then the circuit 1 and circuit 2 might not operate as they should. So adding a decoupling capacitor right next to the IC pin, it helps in containing this noise produced by the IC as well as providing the instant current required by this IC. Sorry for the certain background change. There was some work going on. Anyways, the key takeaway from this decoupling capacitor is that whenever you are designing a prototype and you need to use some fast switching IC or a microcontroller, then you need to put some capacitor called the decoupling capacitor, typically in the range of zero point 0.1 microfarad or 100 nanofarad. You put it right beside the IC's power pin. Okay, so it will serve two purposes. The first one is it will provide the instantaneous current, and the second purpose is it will help prevent the noise from escaping to the other parts of the circuit. Now let's just see a very practical use of these decoupling capacitors in a very commonly available development board, Arduino Uno. I hope you are well familiar with this Arduino Uno. So this is the actual circuit diagram of this Arduino Uno. We don't have to go very deep into it. I'll just focus on one thing. So ignore all these, ignore all these other circuits. We'll just focus on the decoupling capacitor part. Okay. So you can see here that this is the VCC pin of some IC. Okay. This is the VCC pin of this 8 mega IC. Okay, and we see that 5 volt power supply is added to this VCC pin, and you see if you follow this wire, you will also see that there is a 100 nanofarad capacitor attached to it, right? So this is the decoupling capacitor. Okay, similarly, let's just see some other pins. Yeah, right here. So on this IC2, see this is the VCC pin, and it is being supplied 5 volts power supply, and there is some 100 nanofarad capacitor. So whenever you are designing some fast switching circuit, you will put you'll put a decoupling capacitor, typically 0 0.1 microfarad, right next to this IC pin. Okay. Now, if we go back to our project that we are building, this motor driver, uh, you will see these these two bulk capacitors. Okay, these two bulk capacitors. Their purpose is slightly different from these decoupling capacitors. And in case you're wondering, this 220 is the value of this capacitor. So it's a 220 microfarad capacitor. This 35 volts means it's the operating voltage that it can operate on, up to 35 volts. And this VT is just some manufacturing number that they use. Okay, so these are some bulk capacitors. They're slightly different than the decoupling capacitors that we have just seen. Now let's just quickly understand the purpose of these bulk capacitors. Okay, so you will have your motors, on these pins here, here, and here. Okay, so let's just say you're connecting some motors. Okay, you're connecting some motors, and these motors, it will demand some current. Okay, it will demand some current, and this capacitor this capacitor will provide that sudden increase in current. Okay, now you might wonder that what is the difference between this bulk capacitor and a decoupling capacitor. Well, the difference is in the amount of current as well as the frequency. So to graphically understand this, let's just consider something like here time, okay, and here current. For the IC, the current graph will look something like this. Okay, it will require some current, suddenly it will drop. It will require some current again, suddenly it will drop. It will require some current, suddenly it will drop, and it will go on something like this. Okay, so you can see the frequency. Okay, the frequency at which this current is changing is very high. Okay, and that is where we use decoupling capacitors. But in case of these motors, okay, this frequency won't be that high. Okay, it will look something like this. Okay, maybe when the motors are starting, it will require a large amount of current. See, the current is higher. Okay, the amount of current is higher, but this frequency is slower. Okay, something like this. Okay, it won't be like a sinusoidal wave. It will depend on if the motor is starting or stopping. But I think you get the idea that if there is a large current but it is slowly changing, we are using some bulk capacitors. But in case of an IC, the current is changing very fast. It's a smaller amount of current, but it's changing at a very faster frequency. Okay, that is where we use the decoupling capacitors. Okay, now the concept that you need to be familiar with is, so whenever is a dynamic load, so in our case a motor or maybe some high powered servo, so we need to use some bulk capacitor. Okay, we need to use some bulk capacitor to cater to its current needs. Okay, and this second capacitor you can see, so this capacitor will mainly serve the purpose of providing the current, this slow surge in current. And this second capacitor, okay, this second capacitor, it sits right next to this voltage regulator. Okay, this is the voltage regulator, and what it will do is it will filter out some noise or ripples from the power supply. Okay, so the voltage regulator is a stable supply. So to quickly summarize, these bulk capacitors, they help in handling sudden load changes. They help in reduce the ripple and noise from the power sources, okay, that might fluctuate. And the typical value for this bulk capacitor is up to 1000 microfarad. We use electrolytic or tantalum capacitors. I'll briefly come to this electrolytic, tantalum, and ceramic part a bit later. Okay, I'll briefly explain why there is a subtle difference between them. And typically, we use these bulk capacitors near the power pins of voltage regulators or power supply. The thing that you need to remember is whenever you are using some dynamic load, okay, for example, here we are using some motor, okay, so whenever you are using some dynamic load that draws a large current, and the frequency of this large current, the current charge is a bit slower than an IC, then it needs some local power supply. So here the capacitor, it is acting as a local power supply for that, for a very brief period of time for that motor. Okay, now don't think that this capacitor is generating some electrical current or some electrical current energy by itself. Okay, it is getting charged and discharged by this power supply, but for a very brief period of time, it is being able to release that energy. Okay, let's quickly see what is all this electrolytic capacitor and ceramic capacitors. Well, let me show you a picture of electrolytic capacitors. So you can see these kinds of capacitors are called electrolytic capacitors. They are mainly made up of some aluminum oxide. Okay, they will have a shorter leg as well as a longer leg. So you can see in this picture there is a shorter leg and a longer leg. So we'll connect the longer leg to the higher potential and the shorter leg to the lower potential. So in this electrolytic capacitor, the polarity of the component will matter. Okay, it's a polar component, so you cannot connect it in reverse. Okay, you have to connect the longer leg to the higher potential and the shorter leg to the lower potential. Now let us see the ceramic capacitors. So these are the ceramic capacitors, and unlike the electrolytic capacitors, they are non-polar. So it doesn't matter which way you connect them. MLCC stands for multi-layer ceramic chip capacitor. You can see there are a lot of ceramic layers, and in between there is a dielectric. They are very cheap. So unlike the electrolytic capacitors, which are mainly preferred in low frequency uses, just we have seen in our motor driver case, these MLCC capacitors, they are typically used in high frequency use cases, just like some IC switching. So you will put one of these capacitor right next to the IC pin. So in this session, we mainly looked at capacitors because they are the most frequently used component in PCB design, and you need to be very comfortable while using them. So I hope I have given you some brief idea on how to use them and why we're using them. That is more important. The why we should use a certain component is the question you should ask while building your own projects to get a deeper understanding of PCB design. We briefly touched on decoupling capacitors. We also discussed bulk capacitors, the difference and use cases of electrolytic and ceramic capacitors. And on the next session, we'll start with the physical layout of our motor driver project and understand how the schematic is being converted to an actual physical design. Thank you.